Hey everyone, thanks for coming out. As you saw this talk, we had quite a bit of setup, so this is either going to be fantastic or a flaming mess. Either way, it should be entertaining. My name is Rowan, and presenting with me today are Aditi and Bree. The three of us are program managers on the .NET team at Microsoft. We're going to do a bit of a fun talk. There's been lots of talk about AI and ML, lots of breakout sessions with details. We just thought we'd show some fun ways that you can plug AI and ML together. Now, the things we demo probably aren't things you're actually going to do in your day job, but the idea is to show how easy it is to use the technologies around to do AI and ML with .NET. When we think about the ML space, there are two categories of offerings. There's out-of-the-box pre-trained solutions. So this would be things like Azure Cognitive Services, where you send in some input, and you get back a result, and you don't have to worry about training the model. On the other end of the spectrum, we have custom solutions. This is where you're responsible for building the model and then consuming it. So this would be good in situations where there is no out-of-the-box offering, or if your domain doesn't work well with an existing offering. Maybe your text analysis has some very specific keywords that aren't going to work with something more general. For our talk today, we're going to focus on two different technologies. We're going to use Cognitive Services, and then we're going to use ML.NET. So we're going to start with ML.NET. I'm going to hand off to Aditi. If you were in my theater session earlier today, you will have seen the more detailed version of this demo. So when you start to see something you've already seen, don't fret. It's going to be a quicker overview, and then we'll move on to some other demos.
Awesome. So for those of you who haven't made it to any of our other ML.NET sessions, ML.NET is an open source and cross-platform machine learning framework made with and for .NET. And so today I'm going to show you a scenario where I actually have a piece of damaged music, so music with notes missing, and I've trained a model in ML.NET to be able to predict what the missing notes should be and fill them in. So let me give you a sample of the damaged music. Nope, wrong one.
Yeah, it'll go.
Great. So you can see here that there's some obvious things missing in this music. We're represented by these spaces here. For those of you who are music connoisseurs, you notice that this isn't completely rendered correctly, but you kind of get the point here. So if I play this, so as you can tell, that didn't sound super great. There's obviously some stuff missing in here. So let me jump into the code to show you how I'm actually going to fix this.
Did you want it?
Thank you. So here I have the JSON file that kind of represents the melody that I was just showing you. And all I've done is parse that file into a bunch of notes that are represented by numbers. So you can see here note 69. And those missing notes are represented by note equals 0. So we've kind of filled that in and hard-coded that in here for this melody in particular. So if we take a look at the data set that I used to actually train this model, this is the first step that you have to take when actually building your model. So this is the data that I actually started with. This is basically a bunch of songs that I have, and in it is all the pitches in each individual song and the duration of all the pitches and a bunch of other information. But not all of this information was necessary, and not all of this was useful for being able to train my model. So I actually went ahead and did a transformation to be able to make it in a way that's consumable for my model. So a quick music 101 for those of you who don't know a lot about music. So one measure is kind of a standard in music, and it represents a set of notes. And so what I've done here is transform the data set into a way that you're going to predict the note that's missing, which is highlighted in pink here, based on the other notes that are surrounding it in the measure. So this would be a classification problem. You're basically looking at the context in the measure and then figuring out what's missing here. So let's swap back to my code. And walk through my model. Thank you. So since Rowan did a deep dive of this earlier in his session, I'm going to walk through this pretty quickly. But hopefully you get the idea of how I built this model. So let's take a look at this train code here. The first step I've done is to create a new pipeline. So a pipeline is a really important concept in ML.NET. And your pipeline allows you to load your data in, to transform your data, and then actually train your model. And this is kind of the basis for starting the whole model generation process. So after creating this new pipeline, I've added in the data. I've transformed the data in a way that will be understandable and consumable for my learning algorithm. I've specified, hey, this is a classification problem, so I want to use this specific learner that's to do with classification. And then here I'm actually saying pipeline.train, and this is taking that input and the output and training my model. Oh, the font bigger, sure. Yeah. I'll make it a little smaller so you can see what's going on. Sure. Hopefully this is better. I'll just show you that again really quickly. So creating a new pipeline right here, transforming my data here, adding a learner, and then calling pipeline.train here. And then the last step here I've done is to actually write the model to a zip file that I can then take and drop into my other application that I was showing you, so I can actually consume it and use it to predict. On the bottom here, I've just actually created a test case so I can tell if my model is working before I go ahead and drop it into my other app. So this is just going to run a prediction when I'm building the model and make sure that, hey, everything's working correctly. So let's go ahead and run this. And you can see that it went through a few steps, and it actually predicted correctly. It says, hey, for this measure, the node is A. And that's actually correct in the scenario that I provided it. So now that I've trained this model, I can go and find it and drop it into my other project. So if I go here, open my files, go into my bin folder, you see musicmodel.zip has been created. So I'm just going to copy this, go into my other application, and paste it here. And now it's been added, as you can see down here. So now that I've added my model in, I can actually go and consume the model in this app and use it to predict those missing notes that you saw before. So let's go to Music Repairer and fill in some code. The first thing I'm going to add in here is building the features out. So this is taking the data set that I showed you, the song that I showed you that has the missing notes, and just turning them into those measure contexts that I showed you before so that we can input this into the model. So the data has to be in that same format that I showed you before. The second thing I'm going to do is actually load the model. So I'm calling load model, and then model.predict will take in that feature that I just defined here and make a prediction. And then the last thing I'm going to do is convert that note back into a number. So if you saw that the notes all have letter names, but to actually play them, we're going to have to convert them back into the numbers that I was showing you in the JSON file in the beginning. So I'm converting that back into a number in this last step. So I'm going to rebuild this project and then rerun it, and we should see some actual good music now. And look at that. Instead of spaces, where you see the notes in red is actually where we filled in with predicted music. So let me play this for you. You can see it sounds a whole lot better than it did before.
All right, so we've seen something with ML.NET. Thought we'd swap gears a little bit now and look at something using Cognitive Services and the Text Analytics API. So in our application, we've implemented a few different pages. One of those pages is it loads up some feedback that has been provided to the .NET team over time. This was scraped from blog posts. And what we'd like to be able to do with this data is detect whether it's a positive or a neutral or a negative sentiment, which is a perfect use case for the Text Analytics API. As you can see at the moment, we have the bar down the bottom, which is just grayed out because we have not implemented this functionality yet. So I'm going to swap back to our application. The class that's responsible for loading the data is this feedback service. And in it, I've installed the Text Analytics NuGet package and created an instance of the API. This is just the wrapper that gives me a nice .NET API over the Text Analytics API. And I've passed in things like the region and my subscription key into that API. Now, before the feedback is passed to the UI to display, it's run through, or it comes from the get feedback, and I've got a placeholder here to implement sentiment analysis. So the first thing we need to do is create some input. Here I'm taking my input and turning it into a batch of feedback that's going to be sent up to the Text Analytics API. So rather than having to do individual calls, I can stack it all up and send all the feedback at once. Then once I've got that, I go ahead and make the API call. Just passing in the batch. Again, this is a nice .NET API, so it's an easy wrapper over the top. And then with the results that come back, I'm going to loop over them. I will find the piece of feedback based on the ID, and then I will set its score to be the score that came back from the Text Analytics API. We'll rerun the application now. And we'll see that we're now getting sentiment coming back. We've got a mix of feedback here, some positive, neutral, and negative. Now, we thought after the music demo that this one seemed a little bland. So we have an Arduino up on stage here that we've hooked up to some lights. And in our application, we've implemented a light controller, which is just using a serial port to communicate with the Arduino. And it's sending through commands to set the color of the lights depending on the sentiment. So swapping back to our API, we can get some nice bit of feedback as we go through these. Now, we were fair too. We picked a nice selection of feedback, some of it negative as well. All right, I'm going to hand off to Bree.
Awesome. All right, so another awesome feature of Cognitive Services is called Face API. What this does is image processing to detect, analyze, and organize faces and photos. And I'll show you right here. So what it does, it'll detect a number of faces and photos, and it will return back a unique face ID for each face that it identifies, and it'll return back facial attributes. This includes predicted gender, predicted age, whether they're wearing glasses or not, and as you'll see in this demo, emotion. So the way that it returns emotion, as you can see up there, as a confidence score between 0 and 1, 1 being most confident that the face detected in there is actually demonstrating that emotion, 0 the least confident. And it'll return, for anger, contempt, disgust, all the way down to surprise, that score between 0 and 1. So if we switch back here, you will see my face up here, and you'll see that it's not implemented quite yet. I have to bend down a little bit. And I'll snap a photo right now. And you'll see analysis not implemented quite yet. And now I'll go back to the code and implement the Face API. See. Oh, thank you. And so it's very similar to the Text Analytics, where you create a new instance of the Face API. And we'll delete this code here. And what we want to do is we'll have a file stream, so it is a local image file. And we'll set up a list. And we only want it to return the emotion, because as you saw before, it can return a lot of different facial attributes, and all we want is the emotion. We'll go ahead and let's see if we can show this. All right, and so then you make the API call and you put in the file stream and the attributes that you want to get returned. So then, if it does detect a face, it will return back the first face that it finds, and it will only bring back the emotion. And as I said before, it does return a score for all, I think it's 6 emotions. So we actually just created a method so that it will return back the emotion with the highest score. So if we go ahead and implement this now, all right, try this again. You can see that now it is detecting my emotion. And I'll do a few so that you can see. I'm not an actress, so please